Work is done when rubbing your hands. Work can easily be converted to thermal energy. But is thermal energy as easily converted into work? We will answer this question as we discuss heat pump and heat engine. The second law of thermodynamics states that heat by itself cannot flow from cooler object to warmer object because by nature, heat flows from objects of higher temperature to objects of lower temperature. But heat can flow from objects of lower temperature to objects of higher temperature through the use of a heat pump. Heat pump is an effective cooling or heating system. Examples are air conditioning units and refrigerators. A heat pump is a device that allows heat to transfer from a cold reservoir of lower temperature to a warmer reservoir of higher temperature by doing work provided by a motor. What are the parts of a refrigerator? Number 1. Refrigerant. A refrigerant is a fluid that changes phase by absorbing and releasing heat. Number 2. Evaporator coils. It is where the refrigerant absorbs heat from the interior of the refrigerator and changes to gas or vapor. Next, expansion valve or expansion device. It converts high-pressure liquid refrigerant to low-pressure liquid refrigerant. Number 4, condenser coils. It is where the vapor refrigerant releases heat to the environment to change phase from gas to liquid. And lastly, the compressor, where the vapor refrigerant is compressed to become high-pressure vapor. How does a refrigerator work? Heat is absorbed inside the refrigerator and released outside. Specifically, a refrigerator works when the vapor refrigerant flows through the compressor coil to increase pressure to become a high-pressure gas. The high-pressure vapor refrigerant enters the condenser coils to release heat and changes its phase to liquid. The high-pressure liquid refrigerant flows through the expansion valve to become low-pressure liquid. And low-pressure liquid refrigerant flows through the evaporator coils to absorb heat and changes to vapor. What is common between an air conditioning unit and a refrigerator? You will notice that they have similar parts. Both of them have evaporator, condenser coils, and compressor. Looking into the air conditioning unit, you will see that it has a compressor, a condenser, and an evaporator. These components are very important in the role of a heat pump during summer and during winter. During summer, the outside coil serves as the condenser coils, while the indoor coil serves as the evaporator. The heat from the air inside the house is absorbed by the refrigerant and is released outside. While during winter, the evaporator coil is located outside and the condenser coil is located inside. The heat from the air outside is absorbed by the refrigerant in the outdoor coil. Then, the refrigerant in the indoor coil or the condenser coil releases heat to make the room warm. Now, let's proceed to heat engines. A heat engine is a system that converts heat or thermal energy to mechanical energy. There are two types of heat engine. The first type is the gasoline engine. Here are the parts of the gasoline engine. First, the inlet valve. The inlet valve opens to let the air-fuel mixture enter the cylinder. A spark plug ignites the air-fuel mixture. The cylinder is where combustion takes place. Piston moves up and down during compression and combustion. The crankshaft converts linear motion to rotational motion and is connected to the wheels of the engine, while the exhaust valve opens to remove the burnt air-fuel mixture from the cylinder. How does a gasoline engine work? A gasoline engine has 4 strokes, namely intake, compression, power, and exhaust. In the intake stroke, the intake or inlet valve opens and the fuel-air mixture enters. The fuel-air mixture pushes the piston down. In the compression stroke, the inlet valve closes. As the crankshaft rotates, the piston moves up, pushing the fuel-air mixture. As the volume decreases, pressure increases. Temperature also increases. In the power stroke, since the temperature is high, the spark plug ignites the fuel-air mixture. The burning fuel-air mixture expands, pushing the piston down, and the crankshaft rotates. While in the exhaust stroke, the exhaust valve opens, pressure inside the cylinder drops, making the piston rise. As the crankshaft rotates, the piston pushes the burnt fuel-air mixture, and the burnt fuel-air mixture leaves the cylinder. Another type of heat engine is a diesel engine. A diesel and a gasoline engine have similar parts except for the fuel injector for a diesel engine. In a diesel engine, the compression and exhaust strokes are similar to the compression and exhaust strokes of a gasoline engine. Their difference is in the intake stroke, wherein the intake valve opens and only air enters. The air pushes the piston down. And in the power stroke, since the temperature is high, the fuel injector releases fuel into the very hot air. Burning occurs. The burning fuel-air mixture expands, pushing the piston down, and the crankshaft rotates. Always remember that during the adiabatic compression and expansion, no heat is added to or removed from the system. When work is done on a gas by adiabatically compressing it, the gas gains internal energy and becomes warmer. When the gas adiabatically expands, it does work on its surrounding and gives up internal energy, thus becomes cold. This is applied in heat engines. The first and second law of thermodynamics are applied in heat engines. Every heat engine will absorb heat from a hot reservoir, increasing its internal energy. First law. Convert some of this energy into mechanical work. First and second law. Expel the remaining energy as heat, first law, to some lower temperature reservoir, usually called sink, second law. Like for instance, in a gasoline engine, burning fuel in the combustion chamber is the high temperature reservoir. Mechanical work is done on the piston, and expelled energy goes out of the exhaust, or what we call the sink. In the second law of thermodynamics, when work is done by a heat engine running between two temperatures T hot and T cold, only some of the input heat at T hat can be converted to work, and the rest is expelled as heat at T cold. A heat engine is a device that operates when heat coming from the hot reservoir enters the engine. Some of the heat is used for doing work, while the rest is expelled as waste in the cold reservoir, leaving the engine. In symbols, heat coming from the hot reservoir, or Q hot, is equivalent to work done by the piston plus the heat expelled to the cold reservoir. We can write it as W is equal to Q hot minus Q cold. It is also stated in the second law of thermodynamics that not all the heat input can be transformed to mechanical work. Only some can be transformed into work, with the remainder expelled in the process. In symbols, efficiency is equivalent to work done over input heat times 100. In terms of work done is equivalent to Q hot minus Q cold. Therefore, efficiency is equivalent to Q hot minus Q cold over Q hot times 100. Here are equations for ideal efficiency of a heat engine. So you can use these equations in solving for the efficiency of a heat engine. So you can solve using temperature in Kelvin or heat in joules. Feel free to pause this video in order to copy the equations that you will be using later on in the problem-solving activity. This can further be demonstrated in heat engines, wherein the heat coming from the cylinder or the hot reservoir is utilized to do work. As work is done by the piston, some of the energy or some of the heat goes to the exhaust valve or the cold reservoir to the muffler. In the refrigerator, work is done in the heat pump so that heat will flow from the cold reservoir towards the hot reservoir. In heat pumps, like refrigerator or aircon, work is done by the motor or the compressor for heat to flow from the food or inside the room, which is the cold reservoir, to the environment or outside, which is the hot reservoir. During summer, work is done so that heat will flow from the cold reservoir inside the house to the hot reservoir outside the house. During winter, the compressor does work in order for heat to flow from the cold reservoir outside the house to the hot reservoir inside the house. Take time to ponder. Heat by itself cannot flow from cold object to hot object unless work is done. In life, we can reverse the flow by doing work. That ends our session. I hope you learned something from our discussion.